The tracing curve shows contractile responses of skeletal muscle preparation for electrical stimulation, while here, at two different frequencies. The amount of calcium sequestration in the calcium reticulum is highest during which of the following labeled responses. So in order to understand this, what I've given you here is the following. If you look at the tension curve on the left, what you'll notice is the following, that you have peaks and valleys. And the peaks here represent the fact that you have contraction. And what you must think of in the meantime, however, is an action potential on a skeletal muscle, which is then traveling through down the T-tubule, which is then interacting with the dihydropyridine receptors and the ranitidine receptors, and then obviously uncorking the sarcoplasmic reticulum to release that calcium, to then bring about contraction. Well, all that is taking place when you get to that peak. And then you notice that you have these valleys, right? So down at the valleys here, it then represents that contraction has been terminated. And if you recall, contraction is terminated when you remove the calcium from your troponin C and then pump back into sarcoplasmic reticulum. What you notice now is the fact that with each subsequent contraction, you have less and less of the relaxation, and you have more and more of the contraction state. In other words, what's happening is that you have a frequency of increased action potentials moving down the T-tubule, in which you have a process called summation. So these are summation. In other words, you're building upon one type of action potential to increase the contraction, and that's the one on the left. And we'll call this the lower frequency type. But in order to have these pulses of contraction that you see here with the peaks, for example, there's 1, 2, 3, 4 peaks. That means that during each contraction, you're releasing a little bit of your calcium from a sarcoplasmic reticulum, but then when you get down to the valleys here, which represents the relaxation, then no doubt you will then pump the calcium back into SR. Now I want you to compare the tension curve over to the left here to the one in which we're now comparing it over to the right, in which we will then call it the high frequency state. Okay, and then you'll notice here at the high frequency state. Now first let me begin by saying that this particular tetanic contraction, we'll call this tetanus. And tetanus, of course, only occurring in skeletal muscle. Tetanus only occurring in vivo in skeletal muscle, which can never occur in cardiac muscle, because if it did, then the heart would be arrested and we would no longer function. However, our skeletal muscles indeed do undergo these moments of tetanus. And of course, your tetanus here, you want to keep separate from tetany in pathology, which is dealing with hypocalcemia, for example, as seen with DeGeorge. So here, remember that the sustained contraction taking place during the plateau phase is no doubt due to the increased availability of calcium down in the troponin C. In other words, out of the sarcoplasmic reticulum and then bound in the cytoplasm to this troponin C. And so therefore, my educated guess to all of this, and the best answer, is that if they did give you a bunch of curves, and if there were 5 labeled ones as such, then I would choose the one that would have, well, the one that has just one pulse of contraction taking place. So say that you just had one pulse, right, that was taking place like that, or a couple pulses. Then I would choose a curve that looks like this, in which those pulses then represent the release of calcium. So I'll call these pulses here, release of calcium from the sarcoplasmic reticulum, but you also have these increased number of valleys. And the only way that you could have those valleys in contraction being terminated is putting the calcium back in SR. So bottom line is, in order for you to have a quick contraction, relaxation, contraction sequence, you have to sequester calcium at a much faster rate, which then gives you a curve more or less kind of looks like on the left. Whereas the one on the right, you'll notice that we then have this tetanus type with increased contraction, but that would then mean you have increased calcium in the cytoplasm and less of it in the sarcoplasmic reticulum.